the next hour and a half is showcase some of the brilliant works of some extraordinary men and women, works which were spawned by the seminal investigations of Alan Turing. So we sincerely hope that you enjoy the presentations which is coming up, but there is an incentive for you to pay real close attention for what's coming up. Each of you must have received a puzzle, right? So in that puzzle, you will have names which we'll mention over the next hour and a half, and anyone who is able to find the most number of names wins. Well, he or she won't win the Turing Award, but there are some nice prizes. In case of a tie, the winner will be decided by a modern Turing machine. So first of all, we'll start off with a small video on the Turing Award, which ACM has kindly given us. So can we run that, please?
In 1938, Alan Matheson Turing launched the modern computer era with his classic paper on computable numbers. From then on, his ideas would have tremendous influence on the development of computing, an influence that continues to this day. After receiving his PhD in mathematics from Princeton University, he returned to England to become a fellow at King's College. With the outbreak of World War II, he served Great Britain in its government code and cipher school. There he played a key role in breaking the German Enigma codes, which was instrumental in bringing about an Allied victory. In 1945, he led the team that designed and built the Automatic Computing Engine, or ACE, an important early electronic digital computer. Several of his papers are now widely acknowledged as the foundation of research in artificial intelligence. He developed the criteria known as the Turing test, his proposed method to determine whether or not a machine could actually think. Today it remains the measure of artificial intelligence. In 1966, the Association for Computing Machinery instituted the Turing Award to honor the memory of Alan Turing. Over the years, it has become universally recognized as computing's most prestigious award, given each year to individuals selected for making contributions of lasting major technical importance to the computing community. All of us owe a tremendous debt to Alan Turing. It was his originality and vision that helped make the computer revolution possible.
So to start things off, I would like to call on Chubby.
Alan J. Perlis received the Turing Award in 1966 for his influence in the area of advanced programming techniques and compiler construction. He played a leading role in developing ALGOL 60, arguably one of the most influential programming languages in history. He publicly argued for the centrality of programming languages and algorithms as a defining concept in computer science. Equally important during those years was Perlis's leadership in helping to mold the nascent field of computer science into academic discipline. Particularly relevant was the establishment of ACM Curriculum Committee on Computer Science during his term as president of ACM. Maurice Wilkes, the Turing Award 1967 winner, he is best known as builder and designer of the Electronic Delay Storage Automatic Calculator, that is the EDSAC, in 1949, the first computer with an internally stored program. His most important scientific contribution to computing was to come up with a new design principle, microprogramming, that greatly simplified the logical design of the new computer. He was perhaps the first person to recognize that software, a term not used until about 1960, would prove to be a worthwhile academic pursuit. Richard Hamming. He received the 1968 Turing Award for his work on numerical methods, automatic coding systems, and error detecting and error correcting codes. His fundamental paper on the topic, error detecting and error correcting codes, appeared in April 1950 in the Bell System Technical Journal. The paper created an entirely new field within information theory. In 1956, Hamming worked on IBM 650, an early vacuum tube and drum memory computer. His work led to the development of a rudimentary programming language. The Hamming spectral window still widely used in computation, is a special type of digital filter designed to pass certain frequency and discriminate against closely related frequencies. Marvin Minsky. He is the 1969 Turing Award winner for his central role in creating, shaping, promoting, and advancing the field of artificial intelligence. His best known work was from mid-1970s. The central idea was which centers on the family of ideas that he called the theory of frames. When he published the theory of frames, not only offered a fresh way to consider human thinking, but also had a high impact on artificial intelligence, which is an emerging field in engineering discipline. Many consider his 1960 paper, The Steps Towards Artificial Intelligence, to be the call to arms for a generation of researchers. The paper established symbol manipulation, divided into heuristic search, pattern recognition, learning, planning, and induction, to be at the center of any attempt at understanding intelligence. James Hardy Wilkinson, the Turing Award 1970 winner, he received this award for his research in numerical analysis to facilitate the use of high-speed digital computer. He was a British mathematician who became leading expert in a new and important field that emerged after the World War II, matrix computations. One of his problems involved solving 18 equations in 18 unknowns with a hand-cranked mechanical calculator during World War II. That difficult exercise helped Wilkinson to come up with a fresh perspective to account for the round of errors. He also made a major contribution to the eigenvalue problem. John McCarthy, 1971 Turing Award winner in the field of artificial intelligence. His work has emphasized epistemological problems, the problems to determining the information, and the modes of reasoning required for intelligent behavior. He also created the Lisp processor language, the Lisp, which became an important tool in artificial intelligence research and is still widely used. He also made substantial contribution to the algebraic languages ALGOL 58 and 60. McCarthy developed a time-sharing system concurrent with Fernando Corbato's CTSS, which was an essential precursor to the computer networking. Given that McCarthy was primarily a mathematician and technologist who had a little use for exaggeration, it is ironic that his most widely recognized contribution turned out to be 1956 in the field of marketing, specifically in choosing the brand name for the field, namely artificial intelligence. Edgar Dijkstra, the 1972 Turing Award winner for the fundamental contribution to the programming as a high-level intellectual challenge, for elegant insistence and practical demonstration that programs should be composed correctly, not just debugged into correctness, for illuminating perception of the problems at the foundation of the program design. He also pointed out that software productivity and reliability is closely related to rigor in design, which eliminates software flaws at an early stage. Among his other significant contribution is the development of a theory of non-determinacy, an effective tool for reasoning about the programs and simplifying program design. He also introduced the concept of predicate transformers as a basis for defining program semantics. An interesting fact about his well-known shortest path algorithm is that he developed it in 20 minutes while relaxing on a cafe terrace with his fiancée. And the most interesting fact is that we didn't find any marriage entry for Edgar Dijkstra till now. Charles William Beckman, the 1973 Turing Award winner, for his outstanding contribution to database technology. By creating the integrated data store IDS and advocating forcefully the concepts behind it, he became very influential in the creation of database management system as we know it today. Beckman played an important role in standardizing the concepts, terminology, and technologies in the area of database management system. He also formulated the underlying concept of network data model. Beckman was the first Turing Award winner without a PhD, the first to be trained in engineering rather than science, the first to win for the application of computers to business administration, the first to win for a specific piece of software, and the first who would spend his whole career in industry. The next set of Turing Awards winners will be presented by Kevin.
Just a small thing about the puzzle. You need to hand the puzzle immediately after this event. So you'll have to write your name and we'll take the puzzles from you, your sheet, immediately after this event is over. Thank you.
Okay, I shall proceed. Donald Erwin Knuth. He received the 1974 Turing Award for his major contributions to the analysis of algorithms and the design of programming languages, and in particular for his contribution to the art of computer programming through his well-known book series by the similar name. The collection of technique, algorithms, and relevant theory in these books have served as a focal point for developing curricula and as an organizing influence on computer science. In 1977, he began developing a new typesetting system to enable high-quality computerized typesetting. Knuth's system revolutionized digital typesetting. His tech was an early success story for the free and open source software movement. In his honor, ACM has established the Knuth Prize, awarded to distinguished personalities in the field. We are proud of the fact that one of our adjunct faculty member, Dr. Ravi Kannan, is a Knuth Prize recipient. Alan Neville. He is chiefly remembered for his important contributions to artificial intelligence research, his use of computer simulations in psychology, and his inexhaustible, almost infectious energy. His central goal was to understand the cognitive architecture of the human mind and how it enabled humans to solve problems. He was a co-developer of the first list processing language and of programs like the logic theorist and general problem solver, which were designed to use heuristics in solving problems. He also contributed to advances in speech recognition and human-computer interaction. His goal was to make the computer into an effective tool for simulating human-like problem solving, a computer program that solved a program in a way that humans did not or could not, was not that interesting to him, even if that program solved it in a better way. The hope was to develop programs that succeeded at solving problems when and how humans succeeded, and failed when and how humans failed. Herbert Alexander Simon jointly won the 1975 Turing Award with Alan Neville. He had a desire to make the computer an effective tool for simulating human problem solving, which resulted in his development of heuristic programming. He noted that owing to limited information and computational resources, people use simpler heuristics and accept satisfactory rather than the optimal results in order to make decisions or solve problems. He was a co-developer of the first list processing language and of programs designed to use heuristics in solving problems. It is said that before coding the logic theories into the machine, he and his PhD student Neville actually used their family members to simulate the working of the code and to check its correctness. Michael Rabin. He received the Joint Turing Award in 1976 along with Dana Stewart Scott for the paper Finite Automata and the Decision Problem, which introduced the idea of non-deterministic machines, which has proved to be an enormously valuable concept. This classical paper has been a continuous source of inspiration for subsequent work in this field. His work on cryptography started off with a puzzle given to him by another Turing Award recipient, John McCarthy. It resulted in a groundbreaking paper, Degree of Difficulty of Computing a Function and a Partial Ordering of Recursive Sets, which was a starting point for his later advances in a theoretical study of computational complexity, particularly in relation to cryptography. His later work concerns cryptographic problems for preventing piracy on the internet, and he also has been examining how to ensure the privacy and secrecy of online auctions. Dana Stewart Scott was another 1976 joint recipient. He is an influential mathematical logician, and his work spans over computational science, mathematics, and philosophy. Scott's traces semantics has proved to be one of the most influential works in theoretical computer science. One of Scott's major contributions was the theoretical work that allowed the difficult subjects of loops and recursive functions to be included in his denotational semantic structure. He proposed the theory of equilogical spaces as a replacement for domain theory when attempting to define denotational semantics for programming languages, particularly those of functional languages. John Backus received the 1977 Turing Award for profound, influential, and lasting contributions to the design of practical, high-level programming systems, notably through his work on Fortran, and for seminal publication of formal procedures for the specification of programming languages. Programming back at that time meant writing instructions at the machine level. To facilitate the process, Backus invented a program called speed coding, which allowed operations on floating point numbers to be described in a more symbolic form. The ALGOL language descriptions used a context-free grammar to formally describe its syntax, and Backus collaborated with Peter Knorr in developing the Backus-Knorr form notation. BNF represented a significant milestone in the formalization of programming languages. Backus eventually made contributions to function programming with the creation of a new language, FP. Robert Floyd. He received a 1978 award for having a clear influence on methodologies for the creation of efficient and reliable software, and for helping to found important subfields of computer science, namely theory of parsing, semantics of programming languages, automatic program verification, automatic program synthesis, and analysis of algorithms. Before his approach of proving programs correct, ensuring that the program satisfies its specifications required testing with different data sets, examining the output, fixing bugs if they arise, and then repeating the cycle all over again. Errors were often found in large programs years after they had been put into production. Floyd's mathematical analysis was the beginning of a long series of attempts by him and others to prove that a program is correct before it was released to use. He also invented many important practical algorithms like the Floyd-Warshall all-pair shortest path algorithm, Floyd-Sternberg algorithm, etc. Kenneth Iverson. He received 1979 award for his pioneering effort in programming languages and mathematical notation, resulting in what the computing field now knows as APL. For his contribution to implementation of interactive systems, for his contributions to educational uses of APL, and to programming language theory and practice. He strongly believed in the power of appropriate notation as an aid to thought, especially when that notation can be interpreted by a computer. In 1962, Ken published the now classic book, A Programming Language, the title of which gave name APL to his notation. He later went on to develop the programming language APL. Now I would like to call upon Kiran Prasad for continuing the presentation.
Anthony Haar received the Turing Award for his fundamental contributions to the definition and design of programming languages. While studying machine translation with Andrei Kolmogorov, he found the problem of sorting important and then thought of the novel sorting algorithm quicksort. An axiomatic basis for computer programming written by him is one of the most influential papers on the theory of programming. In this, he developed Hall triples for reasoning about programs using specifications of statement behavior. Apart from the Turing Award, he was also awarded the Kyoto Prize in 2000. Edgar Cord is considered as the father of databases. He revolutionized the way databases were perceived. Several database products did indeed exist at that time. However, they were cumbersome, difficult to use, and rested on no solid theoretical foundation. Cord realized the need for such a foundation, and applying his knowledge of mathematical logic, he was able to provide the relational model of data. Stephen Cook received the award for his advancement of our understanding of the complexity of computation in a significant and profound way. Cook presented his seminal paper, The Complexity of Theorem Proving Procedures, that marked the introduction of the theory of NP completeness, which henceforth occupied a central place in theoretical computer science. Cook's paper was also the source of the celebrated and still unsolved P versus NP question. The impact of the P versus NP problem has extended beyond the field of computer science. Dennis Ritchie received the award along with Ken Thompson for the development of generic operating systems theory and specifically for the implementation of the Unix operating system. Ritchie is best known as the creator of programming language C, which was based on an interpretive language called B created by Ken, which he used to implement the non-kernel parts of Unix. Ritchie added types to the B language and later created a compiler for the C language. Thompson and Ritchie rewrote most of Unix in C in 1973 and also presented a paper describing Unix. The Unix system presented in the paper was elegant and simple, providing a useful and extensible multi-user programming environment on an affordable machine. Their model of the Unix system has led a generation of software designers to new ways of thinking about programming. The genius of the Unix system is its framework, which enables programmers to stand on the work of others. Kenneth Lane Thompson wrote the first version of the Unix operating system for a Digital Equipment Corporation PDP-7 in a month, using a cross assembler that ran on GECOS. The PDP-7 he used had only 4K of 18-bit words. He also wrote the then world champion chess playing computer Bell. Noteworthy is Dennis Ritchie's comment about his collaborations with Thomson. It began in 1969 when Ken Thomson discovered a little used PDP-7 computer and set out to fashion a computing environment that he liked. His work soon attracted me. I joined in the enterprise, though most of the ideas and most of the work for that matter were his. Nicola E. Wirth received the Turing Award for developing a sequence of innovative computer languages: Euler, Algol W, Modula, and Pascal. Pascal has become pedagogically significant and has provided a foundation for future computer languages, systems, and architectural research. Computer scientists know that hardware and software design are similarly challenging, but most tend to focus on one or the other. Wirth did both. He seized on the new Field Programmable Gate Array FPGA, a special chip that can be reprogrammed for a particular application, and developed languages and tools to configure them efficiently from a high-level specification. Richard Manning Karp received the Turing Award for his continuing contributions to the theory of algorithms, including the development of efficient algorithms for network flow and combinatorial optimization problems, and most notably contributions to the theory of NP-completeness. Karp showed that the collective failure by many talented people to find efficient algorithms for specific NP-complete problems strongly suggests that no efficient algorithm exists for them. His most recent research has been in computational biology. This work began in the 1990s as the field began to grow rapidly under the influence of the Human Genome Project. Another major theme in Karp's research has been the use of probability in both the design and analysis of efficient algorithms. He showed that, surprisingly, randomizing the behavior of an algorithm can often significantly reduce its expected running time for any input. John Hopcroft received the Turing Award for fundamental achievements in the design and analysis of algorithms and data structures. To start with, he became a computer scientist almost by accident when his department had asked him to teach a class in computing science. He emphasized the need to focus on asymptotic complexity as the size of the problems increased with ever-increasing computing power. This set a new direction in the analysis of algorithms. He explored efficient structures for storing data in a computer and created efficient algorithms for solving the problems they could represent. His work on formal languages and the analysis of algorithms has made John Hopcroft one of the handful of pioneering computer scientists who put the discipline on a firm theoretical foundation. Robert Tarjan received the Turing Award for fundamental achievements in the design and analysis of algorithms and data structures. He emphasized depth-first search as an important algorithmic technique and advocated the use of an adjacency list representation for sparse graphs rather than an adjacency matrix. He also developed a linear time algorithm for finding the strongly connected components. He realized that designing a data structure to minimize the worst case running time for each operation was unnecessarily limiting. What mattered was the total running time of the sequence of operations. Alternatively, from the point of view of the data structure, one could study the algorithm's amortized running time, that is, its average running time per operation over a long enough sequence of inputs. Tarjan's book, Data Structures and Network Algorithms, is regarded as a model of precision and clarity. He co-devised the Fibonacci heap data structure with Michael Friedman. Now I would like to call upon Dilpreet to take forward the presentation.
John Koch, the 1987 Turing Award winner, who made fundamental contributions to the architecture of high-performance computers and optimization of compilers. He decided to design a microcomputer with a small set of basic instructions optimized for use by compilers, which resulted in a simpler and faster machine. This had a broad impact on computer architecture research and was later called the RISC architecture. Cook co-developed interval analysis with Francis Allen, a program analysis technique based on a control flow graph reduction. Cook co-invented many of the optimizing transformations underlying today's compilers. He also led the IBM's first supercomputer project called Advanced Computer System, whose goal was to build a fast computer for scientific applications. The 1988 Turing Award was received by Evan Sutherland for his pioneering and visionary contributions to computer graphics. His doctoral thesis, Sketchpad, was a man-machine graphical communication systems which described the first computer GUI. Sketchpad was a groundbreaking interactive computer-aided design system whose functionality continues to inspire admiration among computer graphics professionals. He co-developed the Cohen-Sutherland computer graphics line clipping algorithm for removing parts of lines that extend beyond the viewing region. In 1968, with the help of his student Bob Sproul, he created the first virtual reality and augmented reality head-mounted display system referred to affectionately as the Sword of Damocles, because it was suspended from the ceiling above the user's head. Starting in the mid-1970s, Sutherland was affiliated with the RAND Corporation and investigated making animated movies, an undertaking well ahead of its time. William Morton Kahan was a 1989 Turing Award recipient for his fundamental contributions to numerical analysis and for his work in creating the IEEE 754 standard, for which he has often been called the father of floating point. Adoption of this standard did a great deal to improve the robustness of floating point arithmetic and improve consistency of results across different computing platforms. He developed Paranoia, a program that tests floating point arithmetic implementation for errors. In recent decades, Kahan has continued to articulate and bluntly warn of the shortcomings in the floating point implementation of environments as popular as Java and MATLAB. Fernando Cobato received the 1990 Turing Award for leading the development of the general-purpose, large-scale, sharing-based computer system. In late 1950s, he became familiar with the limitations of computers. Computers were used by one person at a time and required sign-ups in advance. Some computers were run in batch mode, where professional operators ran previously submitted computational jobs. Both approaches required the programmers to wait for hours or days, and to wait again if the job had to be redone due to an error. His work on time-sharing and resource-sharing computer systems, namely CTSS and Multics, made a paradigm shift from conventional batch mode of processing to time-sharing computer, which allowed several users to connect to the computer at the same time. Arthur Milner received the Turing Award in 1991 for 3 distinct and complete achievements. First, LCF, the mechanization of Scott's logic of computable functions, probably the first theoretically based yet practical tool for machine-assisted proof construction. ML, this first language to include polymorphic type inference together with a type-safe exception handling mechanism, which influenced later languages like Scala, Java, and Microsoft's C#. CCS, Calculus of Communicating Systems, which is a general theory of concurrency. In the year 1992, Butler Lamson received the Turing Award for contribution to the development of distributed personal computing environments and the technology for their implementations, workstations, networks, operating systems, programming systems, displays, security, and document publishing. At Berkeley, Lamson et al. Designed this calc time sharing system for a CDC 6400. This was the first capability-based system to have a real user community. It pioneered the ideas of shadow paging and redo logs. Butler, with Alan Kay, designed the bytecode machine language scheme used for Smalltalk and Mesa. He also devised the access matrix model for computer security, unifying the ideas of capability and access control lists. In the year 1993, Richard Edward Stearns received Turing Award with Joris Hartmanis in recognition of their seminal paper which established the foundations for the field of computational complexity theory. In 1965, in his seminal paper on the computational complexity of algorithms, he proved that a precise definition of the complexity of an algorithm and a complexity class. He also showed that there is an infinite sequence of distinct complexity classes and therefore an infinite sequence of increasingly hard problems. He, along with Philip Lewis, showed that a similar hierarchy exists when the complexity is defined in terms of the amount of memory space required to solve a problem on a Turing machine. The 1993 Co-Award winner Joris Hartmanis's work on the foundation of complexity theory was instrumental in establishing computer science as a formal discipline. Hartmanis established complexity theory as the dominant theme in theoretical computer science. Hartmanis and his student Leonard Baumann showed that all natural NP-complete sets are isomorphic, and further showed that complete sets computable in exponential time cannot be sparse. Now I will invite Sachin to present the next few Turing Award winners.
Dabbala Rajgopal Reddy received Turing Award in year 1994 and joined with Edward Feigenbaum. Reddy is the only Indian who has received the Turing Award for pioneering the design and construction of large-scale artificial intelligence systems, demonstrating the practical importance and potential commercial impact of artificial intelligence. Reddy and his colleagues have also made seminal contributions to other areas of artificial intelligence and computer science, notably to task-oriented architecture, analysis of natural scenes, autonomous robotic systems. The Blackboard architecture for coordinating multiple knowledge sources developed under Speech Understanding Research Program at Carnegie Mellon has been widely adopted. From about 1975 on, Reddy's research interest expanded in several directions. He was one of the major collaborators at Carnegie Mellon with DARPA and was instrumental in getting DARPA work started on VLSI research, sensor network, operating system, and workstations. In year 2005, Reddy was honored as the first recipient of Moza bint Nasser Chair of Computer Science and Robotics. In year 2001, Reddy was awarded the Padma Bhushan. Edward Feigenbaum also received Turing Award along with Raj Reddy for the same contribution. Feigenbaum and colleagues developed heuristical Dendral, a computer program that could guess the geometrical structure of complex chemical given their chemical formula and their mass spectrum data. Apart from his work with Raj Reddy, he went on to develop expert system programs in medicine, molecular genetics, X-ray crystallography, and analysis of pulmonary function. He also developed the first transportable general purpose expert system called Shell. Feigenbaum also co-founded 3 companies involved in applied artificial intelligence named as IntelliCorp, Technology, and Design Power. Manuel Blum received Turing Award in year 1995 in recognition of his contributions to the foundations of computational complexity theory and its application to cryptography and program checking. He also developed machine-independent theory of complexity. In 1984, with his student Lenore Blum, he gave a good PRNG based on discrete logarithmic problem. And finally, in 1986, he gave a public key encryption scheme based on Blum-Blum-Shub generator. In the late 1960s, Blum was convinced that computing the medium does require n log n steps. But with a most pleasant surprise, in 1971, he came up with an algorithm that finds the median in linear time. Blum with his student Von Hahn came up with the idea of a visual challenge known as CAPTCHA. Amir Nuli received Turing Award in year 1996 for seminal work introducing temporal logic into computer science and for outstanding contribution to program and system verification. Amir's 1977 seminal paper, The Temporal Logic of Programs, revolutionized the way computer programs are analyzed. Amir's paper introduced the notion of reasoning about programs as execution paths, which breathed new life into the field of program verification. In year 2000, Amir was awarded the Israel Prize in field of computer science for his breakthrough contribution in the verification of parallel and reactive systems by the introduction of specification language of temporal logic. He took active part in an Israeli youth movement affiliated with Labour Party whose focus was on collaboration between academics and labor. Douglas Engelbart received Turing Award in year 1997 for an inspiring vision of future of interactive computing and the invention of key technologies to help realize this vision. His numerous technological innovations were crucial to the development of personal computing and internet. His work helped to change the way computers work, from specialized machinery that only trained technicians could use to a medium designed to augment the intelligence of its users and foster their collaboration. His work on augmentation of human intellect at Stanford Research Institute produced many crucial hardware and software innovations, such as the mouse, integrated email, display editing, Windows, and cross-file editing. James Nicholas Gray received Turing Award in year 1998 for seminal contribution to database and transaction processing research and technical leadership in system implementation. He designed end-user-oriented performance benchmarks and helped establish a vendor-neutral organization, the Transaction Processing Performance Council, to oversee their impartial implementation. This led to more than a decade of strong competition between vendors to improve their products. Gray, along with Gordon, had set up Microsoft Advanced Lab in San Francisco dedicated to servers and scalability. He played a role in developing Terra Server, which allowed access to satellite imagery with high resolution. His work impacted almost everyone involved commercially or academically in the field of online transaction processing. Frederick Brooks received Turing Award in year 1999 for landmark contribution to computer architecture, operating system, and software engineering. He helped design the IBM 7090 stretch supercomputer, so called because it was considerable stretch to the technology and performance of most computers of that time. He is best known for managing the development of IBM's System 360 family of computers and the OS 360 software support package, then later writing candidly about the process in his seminal book, The Mythical Man Month. Brooks coined the term computer architecture to mean the structure and behavior of computer processor and associated devices, as separate from the details of any particular hardware implementation. Andrew Chi-Chi Yao received Turing Award in year 2000 in recognition of his fundamental contribution to the theory of computation, including the complexity-based theory of pseudo-random number generation, cryptography, and communication complexity. In year 1977, Yao introduced the min-max principle in his paper, Probabilistic Computations Towards a Unified Measure of Complexity. Yao's principle has become a fundamental technique for reasoning about randomized algorithm and complexity. In year 1981, with Danny Dolev, he introduced a formal method, Dolev-Yao model, for symbolic reasoning about security protocols. In year 1986, Yao moved to Princeton University. During this period, he worked on the foundations of cryptography. He worked in areas such as decision tree and communication complexity. He also made substantial contributions to the theory of lower bounds of algebraic decision trees. Now I would like to call upon Saurav Mandal to take presentation further. Thanks.
Ole Johan Dahl received the Turing Award in 2001 with Christian Nygaard for the ideas fundamental to the emergence of object-oriented programming through their design of programming languages Simula 1 and Simula 67. Simula contributed the process concept which enabled programmers to express activities going on concurrently. Simula, along with C, influenced the development of C++. In the year 1957, working with Norwegian Defense Research Establishment, NDRE, Dahl designed and implemented a high-level language for the Mercury called MAC, Mercury Automatic Coding. The ideas, objects, inheritance, and modularity are among the major contributions of Dahl and Nygaard to the discipline of programming. Christian Nygaard is the co-winner of the Turing Award in 2001 with Ole Johan Dahl. Nygaard with Peter Handlichen and Erik Holvik Hansen developed a system description language, Delta, which was used to aid in modeling real-world systems. When Christian was a visiting professor in Aarhus University, Denmark, he initiated work on beta programming language. Like Simula, beta language is a language for describing modeling for the real world. But in the tradition of Simula, it was also to be useful as an implementation language. Now, the next 3 award winners are instrumental in the making of modern e-commerce more feasible due to their work in security. In the year 2002, Leonard Max Edelman got the Turing Award together with Ronald Rivest and Adi Shamir for their ingenious contribution to making public key cryptography useful in practice. He designed and developed the RSA public key crypto system along with the co-winners. RSA is now the most widely used encryption method with applications throughout the internet for secure online transactions. Lane also worked on Fermat's last theorem, and in 1986, with colleagues Roger Heath Brown and Etienne Faury, proved that the first case of the theorem holds for the infinitely many primes. In 1980s, with David Ufsey of University of California at San Francisco, he developed a theory of CD4 cell depletion in AIDS as homeostatic mechanism failure. Ronald Reen Rivest is one of the winners of the Turing Award in 2002 for designing RSA public key crypto system. The RSA method relies on the fact that nobody has yet developed an enough efficient algorithm for factoring very large integers. In addition to RSA scheme, Rivest invented symmetric key encryption algorithm like RC2, RC4, RC5 and also co-authored RC6. Rivest's interests in security are not limited to encryption. He is a member of the US government technical committee that develops election guidelines. In 2006, he developed a novel 3-ballot voting scheme. Adi Shamir is co-winner of the Turing Award in 2002 together with Edelman and Rivest. He is an internationally recognized cryptographer. He has a number of claims of fame, including being a co-inventor of the RSA public key cryptography algorithm for encoding and decoding messages, co-inventor of a zero-knowledge proof scheme that allows one individual to show that they know certain information without actually divulging it. Shamir also invented the Shamir secret sharing scheme, in which a number of pieces of secret are shared between individuals. It requires either some or all of them to collaborate in order to reveal the total secret. Shamir also proposed an identity-based encryption scheme, which was of interest because it didn't require the user to obtain a public key to be used in encrypting a message. Alan Kay received the Turing Award in 2003 for pioneering many of the ideas at the root of the contemporary object-oriented programming languages, leading the team developed Smalltalk and for fundamental contributions to personal computing. Smalltalk was designed as a graphical programming language, and it soon became a complete integrated programming environment with a debugger, object-oriented virtual memory, an editor, screen management, and user interface. Smalltalk was the first dynamic object-oriented programming language. Alan Kay envisioned a small computing system in 1970s, long before the notebook computers were available, and hence some consider him as the father of the personal computer. Vinton Gray Cerf received the Turing Award in 2004 along with Robert Elliott Kahn for pioneering work in internetworking, including the design and implementation of the Internet's basic communication protocol TCP/IP and for inspired leadership in internetworking. They formulated fundamental design principles of networking, specified TCP/IP to meet these requirements, prototyped TCP/IP and coordinated several early TCP/IP implementations. In the year 1982, Cerf became the Vice President of Digital Information Services at MCI, where he created MCI Mail, the first commercial email service to use the internet in 1989. In 1986, Cerf joined CNRI as vice president. In 1991, recognizing the need for a neutral forum for internet standards development, Cerf and Khan founded the Internet Society ISOC, an international non-profiting organization. Robert Elian Khan received the Turing Award in 2004 together with Cerf. In 1972, Khan organized the first public demonstration of the ARPANET at the October International Computer Communication Conference in Washington, D.C., which encouraged the people at the various sites to bring new applications online, making the network more attractive to the users. The effect brought the ARPANET to maturity that introduced the network to the larger computer science world. In the spring of 1973, Khan approached Cerf with the idea of developing a system for interconnecting networks, eventually called the Internet. Khan and Cerf demonstrated farsighted leadership by inviting networking experts from around the world to weigh in on the Internet design at a seminar in June 1973. This move led to more robust protocols and laid the groundwork for the global spread of the Internet. Cerf and Khan outlined the resulting Internet architecture in a seminal 1974 paper, A Protocol for Packet Network Intercommunication. Now I would be followed by Subham.
So in the year 2005, Peter Knorr received the Turing Award for fundamental contributions to programming language design and the definition of ALGOL 60, to compiler design and to the art and practice of computer programming. By the age of 12, astronomy became Peter's main passion, and by the age of 15, he had already written his first scientific paper. In the late 1950s, after joining Copenhagen's Computer Center, Peter participated in the development of the programming language ALGOL. During the rest of the 1960s, Peter played an increasingly important role in establishing computing as an academic field in Denmark. In 1966, he defined the courses he was teaching as datalogy, since he disliked the term computer science, and this term has been adopted in Denmark and Sweden. In year 2006, Frances Elizabeth Allen won the Turing Award for pioneering contributions to the theory and practicing of optimizing compiler techniques. She laid the foundation for modern optimizing compilers and automatic parallel execution. Allen worked on the parallel translator PTRAN in IBM, which was a system for compiling Fortran programs not specially written with parallelism in mind. Using her extensive experience with interprocedural data flow analysis, she produced new algorithms for extracting parallelism from sequential code. She introduced the concept of the program dependence graph, a representation now used by many parallelizing compilers. Allen and her team designed a single compiler framework to handle three very different programming languages: Fortran, Autocoder, and the new language Alpha, which was an extraordinarily ambitious effort for the time. The next three award winners, Edmund Clark, E. Allen Emerson, and Joseph Sifakis, won the Turing Award in 2007 for their role in developing model checking into a highly effective verification technology, which is now widely adopted in software and hardware industries. Edmund Clark, with his student Allen Emerson, saw an important possibility in temporal logic. It could be directly checked by machine. They realized that a program could exhaustively construct every possible sequence of actions a system might perform, and every action it could evaluate a property expressed in temporal logic. This gave birth to the technology of model checking. In the 1980s, he co-invented computation tree logic. He is also the recipient of the 1998 ACM Paris Kanellakis Award for Theory and Practice for Symbolic Model Checking. E. Allen Emerson in the 1980s worked with Clark on the computation tree logic. In 1981, Clark and Emerson founded model checking. This is a verification technology providing algorithmic means for determining whether an abstract model representing, for example, a hardware or software design satisfies a formal specification expressed in temporal logic. Moreover, if the property does not hold, This method identifies a counterexample, which shows the source of the problem. He's also the recipient of the ACM Paris Kanellakis Award. In 2007, Joseph Sifakis was the co-winner, and from 1974 to 1977, he worked on Petri nets and other models for concurrent systems. He obtained original and fundamental results on the structural properties of Petri nets, as well as on the performance and evaluation of timed Petri nets. These results are extensively used today for scheduling data flow systems. From 77 to 82, he worked on verification of transition systems and yielded original results on the algorithmic verification of concurrent systems, which was based on a fixed point characterization. In 2008, Barbara Liskov won the Turing Award for contributions to practical and theoretical foundations of programming language and system design, especially related to data abstraction, fault tolerance, and distributed computing. In 1968, she became one of the first women in the United States to be awarded a computer science PhD. At MIT, she led the design and implementation of the CLU programming language, which emphasized the notions of modular programming, data abstraction, and polymorphism. So these are the concepts which are the foundations for modern object-oriented programming like Java and C#. Her research has also covered many aspects of operating system and computation. In 2009, Charles Thacker received the Turing Award for pioneering design and realization of the first modern personal computer, the Alto, at the Xerox Palo Alto Research Center, and seminal inventions and contributions to local area networks like Ethernet, multiprocessing workstations, snooping cache coherence protocols, and tablet personal computers. At Berkeley Computer Corporation, Thacker was responsible for the design of the microprogram processor. He also designed equipment for supporting remote users by concentrating their traffic over the fastest available data connection available at that time, 2400 bits per second. In 1980, he started the Dragon project based on LSI, large-scale integration, and Dragon was a multiprocessor that employed one of the first cache coherence protocol. In 1997, he joined Microsoft Research to help establish the Microsoft Research Cambridge in Cambridge, England. In 2010, he designed Beehive, a simple multiprocessor system running on the Xilix environment board. 2010, Leslie Gabriel Valiant received the Turing Award for transformative contributions to the theory of computation, including the theory of probably approximate correct learning, PAC, the complexity of enumeration of algebraic computation, and the theory of parallel and distributed computing. His research has opened new frontiers and includes the study of both natural and artificial phenomena. The natural studies encompass the algorithms used by computing objects such as the human brain, while the artificial include computers and their capabilities. He showed that although there is an efficient algorithm to tell whether a graph has a perfect matching, there is no efficient algorithm to count perfect matchings unless P equals NP. And in fact, the counting perfect matchings is as hard as any counting problem. In 1990, he proposed bulk synchronous parallel model of communication. In this model, the individual processors need not work in lockstep, but can each perform computations locally and can only communicate the results between intervals. In 2011, the Turing Award was won by Julia Pearl for his fundamental contributions to artificial intelligence through the development of a calculus for probabilistic and causal reasoning. Pearl invented the Bayesian network for defining complex probability models. This work not only revolutionized the field of artificial intelligence, but also became an important tool for many other branches of engineering and natural sciences. He later created a mathematical framework for causal inference that has had significant impact on the social sciences. He created the representational and computational foundation for the processing of information under uncertainty. Thank you. So regarding the puzzle, so you can just write your name and email address, and you can either hand it to Nikhil, who is standing at the back, or Anita, she's here. So we have to thank Satyanath Bhatt for coming up with the program for generating this puzzle. So he's worked till late at night. So thanks.
So what time do we reconvene? Okay. So, so do we come back at 4 o'clock? Okay. 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 So please come back by. So we'll make a brief announcement, and we'll come back. So there's a tea break now. Please come back by 3:55 so that we can begin. Just a brief announcement.